As awesome as the power rule is, it has such limited scope, it needs some friends. So here comes the first friend. And this thing will power up your derivatives, your ability to handle crazy functions. It starts off as a fairly simple rule. This is the product rule, h at x, given h at x equals f at x times g at x, the derivative of h at x. So you've got two things multiplied together. To find this derivative, you go f prime g plus g prime f. Now, I understand when you first see f prime g plus g prime f, you're a little confused. I'm going to tell you, by the time we finish this chapter, you're going to love stuff like this. You're going to be talking to each other and say, what's the product rule again? You go, f prime g, g prime f. You know what I mean? Like it's handy, but when you're first learning it, it seems like gibberish. But hopefully, as I explain this lesson, you'll get used to this f prime g and g prime f. Understand what it's used for, when we want it, and why the short form's so good. For now, what's in the thought bubble is much better to learn what's happening. If you've got a product, two things multiplied together, you go derivative of the first times the second plus the derivative of the second times the first. That's all there is to it. It's actually pretty simple. I will prove it when I get time to do the formal proofs. And again, I'll baby bear, mama bear, papa bear them, so you got a feel for what is a fair proof for this upcoming test. You got to see this in action. I'll come back to this slide, okay? You got to see it in action. For now, out of that, you're like, okay, so apparently, derivative of the first times the second plus derivative of the second times the first. Apparently, that's what the deal is. You'll see what happens. Please note the first few you might look at and go, I don't need any new rule to do these. Like a lot of things in math, we have a new rule and we go try it. We try it out on some easy stuff, getting ready for tougher stuff later. Okay, so if you look at these and go, well, why would you do it that way? I wouldn't. I'm just practicing the new rule. Let me just expand this out. Did I put them on separate pages? No, I didn't. Okay. Got to buy myself a little space here. This guy down by the garbage here. There we go. Now here's, in that whole thing you might have been like, what do you mean first, second? Here, look at this thing. There's a definite first function, which I'm going to underline. You're going to see me do this a lot in this next few sections where I go, let's just underline that so we're clear what we're talking about. There's a first function, 3x to the power of 4, and that's being multiplied by a second function, 5x cubed plus 5x minus 7. I actually could have put this in your last section of homework, because you can just multiply out the brackets. I totally get it. Yeah? But where we're headed is to an example very soon where it's more like, oh yeah? What if I put a 4 there? Now expanding it out is not quite the same game, all right? So just trust me that it's good to practice on these pretty easy ones that we could do another way, getting ready for the tougher ones, okay? So, two things multiplied together. Here's what the product rule says to do, very, very slowly. If you want to find the derivative of this, you take the derivative of the first function, the derivative of 3x to the power of 4, which if you've done, even if you haven't done any of that homework yet, derivative of 3x 4, we're just picking up where we left off. 4 times the 3 is 12, reduce the power by 1 is 12x cubed. And I underline that. As I'm learning, I just underline that. Okay, there's the first. Derivative of the first. Then it says, the product rule says, derivative of the first times the second. And you don't do anything to the second. When it says times the second, it really means just multiply by the second function. Derivative of the first times the second plus derivative of the second, and again, even if you haven't done much of this homework, find the derivative of that second function. You see, by not underlining it, it's underlined in my brain. I can now see. Do you see that little bit of underlining allowed me to go, there's first function, there's second function. Second function derivative is 15x squared plus 5. I'm not going to underline that. I never underline the second function. I'm totally lying. I might underline the second function and later, way later. But when I'm first learning product rule, underline that first one. And whenever you deal with the first one, underline it so you can keep track of what's going on. Doing this really slowly. Derivative of the first times the second plus derivative of the second, shouldn't be too hard to do derivative of the second, times the first. And when I say times the first, not times the derivative of the first, just times the first function. That's actually the end of the product rule lesson. The rest of this is just algebra. is just getting more and more tough situations with the algebra. Sort of like last lesson. The whole last lesson was just bring down the exponent and reduce it by 1. Now let's just work on all the algebra that pops out of that. And that's the same that's happening here. Well, we got a little more work to do. We've got to multiply out these brackets. Because in other examples, it could be by multiplying out the brackets, there's some simplification that can happen, some factoring, some collecting of like terms, all those things. So hopefully this part is not too mind-boggling. Whenever I expand a line, I always immediately look. How frustrating it is, I don't know if you got to an example like this, where you make a mistake up here, and 5 lines later you realize you made a mistake, and then you got to go back and find it. So I built in a double check in my brain. Every time I do a line, then I go, yeah, just double check them right now, so I avoid those mistakes. And now it's just collecting like terms. Is there like terms here? Oh yeah, there's 60x6 and a 45x6. That's 105x to the 6th. And then x to the 4th, 75x to the 4th. Doing collecting like terms right now with the grade 9s. To them, this is a really tough question. And I want to inspire them. I want to show them this video so you see, hey, this is going somewhere. Like, this is not just random stuff I'm showing you. How did I do with the collection? Did I make a mistake there? Let's just rewind to that first slide again to be clear about what we're trying to accomplish and what that rule does. First slide. If you want to find the derivative when there's 2 things multiplied together, take the derivative of the first and just multiply it by the second function. Then take the derivative of the second and multiply it by the first function. No explanation here why this works. I'll get to that in the proofs. Yeah? After saying that a few times, you might be in love with it or you might start to hate it. That's when you switch over to this. You're starting to sound like a calculus person. F prime g plus g prime f. It's a nice way to remember what has to happen. First function, take the derivative. Second function, don't take the derivative. Then, second function, do take the derivative. First function, don't take the derivative. Yeah? So it's a nice little memory tool. Maybe I'll try it out. I'll take it for a test drive on this one here. Two functions not multiplied together. Why is this in the product rule lesson? Well, it's squared. Okay, so I'm starting to give you... By the way, we're going to be able to deal with this squared. We're coming up on something. There's another lesson coming where we'll be able to deal with this squared. For now, right now, you'd have to take this thing and multiply it by itself. What a big mess, right? So I'm going to have to buy myself some space here. Do you need more time here? Because I'm about to resize this whole thing. Oh, I landed right in the garbage. Oh, I got it. Oh, I got it. Oh, it's so good. I'm like Tony Stark up here. To get this ready to do a product rule, I have to rewrite it like this. And you could actually do this function with the weapons I've already given you by just expanding out this unbelievable set of brackets. You get 25 terms, which then you could collect and use the stuff I've already shown you. Okay? But using the product rule, I've got these 2 functions, first and second. And I'm going to try and teach it both ways at once, because it actually doesn't matter which one you use. Whether you use the words, derivative first times second plus derivative second times first, you can use that. Or you can use f prime g plus g prime f. So what I'm going to do is I'm going to do my underline trick. There's first function. But if you want to switch over to be an f and a g person, I'm just going to put a little f under there. Okay? That is my f for this question. And this is my g for this question. So it says derivative of the first, and do it really slowly when you're first doing it. You'll get so fast that you won't even have to think about it. But when you're first doing it, really slowly. Derivative of the first. Or, if you're an f and g person, f prime. Yeah? Real easy to say. This is f, This is f prime. Get rid of the first times the second. So I don't do anything with the second here. Oh, I'm underlining that for you underline people. And that's the G for you FG people. F prime, G. Or get rid of the first times the second. What's next? Plus get rid of the second times the first. The words are nice. They tell you exactly what to do. The F prime G is just fast, you know? So, get rid of the second. Times the first. Or for you people that want to switch over to being F and G people, then I would be F prime G plus G prime F. You see how convenient that is to say? Even if the words are going by right now, even if the letters are going by and you're like, I'm not sure what you're saying with the F prime G and everything like that, you can see the convenience of it. You can get it down to just go, oh, F prime G, G prime F. It's very fast. But if there's any problem at all, the thought bubble is where it's at. Like, to really be good at, to be able to handle these, you just keep reading this over and over and over again. Should I expand these brackets? Oh, I forgot something. Look at, got so caught up in explaining product control, I didn't put the little prime there to say, hey, we're taking derivative there. Yeah? What's that? Well, that's just, I rewrote it, right? Thank you. Only y prime there. There I was just rewriting the function, getting it into a good y setup. Then I went y prime. Now, if these were really, if there was no special little trick here, to really collect this up, you'd have to then multiply it out, and you wouldn't be too happy. Like, you'd be like, are you kidding me? That's a crazy amount of work. There is something about this, and I tried to write it just right so you could see what it is about these two massive sets of brackets that comes out of this. They're very similar. They're shockingly similar. They're the exact same two sets of brackets. So I've got one of them, and I added to it. I really got two of them. So this does a shocking simplification, which is two of these. Saving me all of that work of having to expand out the brackets, because this is in nicely factored form. And I got to tell you, factoring is going to come back and haunt us before we get too much farther here. And when it's in nice brackets like this, we're usually pretty happy with it, if they're just multiplied together. If there's adding between the brackets like this, we're sort of sunk. We've got to multiply it out and collect like terms. When it's all multiplied like this, that's closer to what we want. We want to be factored here, because really, what's coming, to spoil the surprise, is lots of times we're going to say, okay, well, when is y prime equal to 0? And we're going to want this factored. This is pretty close to factored. It's two things multiplied together, whereas this is things added together, which that's not close to factored. Let me fast forward a lesson or two here. Take a look at this, though. See this bracket? It was something squared. The 2 came down, and the exponent on that bracket got reduced down to 1. On the whole bracket, there's a major shortcut coming. Do the derivative move, 2, exponent 1, and then just take the derivative of the inside for some reason. All right, so we're going to get to that, but you see, there's still more. There's more to the story. As awesome as what you've seen so far is, there's more coming. I just don't have all the weapons in your hand yet, so I got to sort of do it with what I've got available. You know, I'm on slide 3 of 5. If your brain is exploding, yeah, two more slides to go. You can already tell that, can you? You can look at your screen. Oh, I got 2 examples and a bonus example. Questions about this? Let's practice another one. More time? More time? Question? Yeah, not very well explained. But for now, you can think, hey, if it's all multiplied together, we like it. If it's added together, we don't like it. And it'll become clear by the time we finish the chapter why multiplied together is really good. And it has to. We're going to set this to 0 a lot of times. to find maxes and mins. And so things that are multiplied together are sort of factored. We like them. Things that are added together, they're not very nice. All right, here we go. The whole enchilada. Again, now I'm addicted to that word, the whole enchilada. That's what I'm doing tonight. The kids go to bed and look up enchiladas, and I'm going to learn how to cook them. They may be terrible, but at least they'll know. No, I won't have to wonder anymore. Again, this is very easy to multiply out the brackets. Absolutely. But when you get to product rule homework, do it with the product rule. Practice with the product rule so that you're really good at it. Just a survey so I know which weight to put on. Are you understanding the words better, or are the F's and G's better right now? How many people are like, I like the words? How many people are like, the F and G is sort of working for me? All right, so I'll try and do it both ways at the same time. Either way, when you're first learning about these, do a little underline of the first one. And for you words people, you'll call that the first function. And this will be the second function. For you F and G people, you'll call this F, and so that other one is G. The rule goes, to take the derivative of this, you go derivative of the first times the second. And I'm speeding up a little bit, not because of the clock, because I have lots of time, and not because I'm trying to show off, and not because I'm bored. Because I'm trying to inspire you that actually once you get a little better at this, these things go pretty quickly. Derivative of the first times the second, plus derivative of the second times the first. Geez, I hope that's enough room there that I've made there. Not I'll have to resize. Let's see. Derivative of the first, yes, times the second. 3x cubed minus 3x squared plus x minus 2, yes. Derivative of the second, 9x squared minus 6x plus 1 times the first. And I've underlined the first function each time there. For you F and G people, this is F prime G plus G prime F. Convenient to say it like that. And I'm not trying to sell you either way. Okay, now I don't know how good a job we did of explaining this situation. So I'm going to ask the question and see if someone can explain. And that'll tell me how well I did making the point. In this situation, am I going to have to multiply out these brackets, or should I just leave them the way they are? And it says you got to multiply them out. What's the one thing in the whole line that tells you you're going to have to multiply them out? Addition. Addition is bad. If we're trying to get to factored form later on in other sections, very soon, this is not moving towards factored form when they're addition. So once addition between, you're stuck. You got to multiply out the brackets. So here they come. Oops. Got distracted there. And like I suggested, every time I do an expansion like that, I like to look back and see how I did. 6x cubed minus 6x squared plus 2x minus 4. 18x cubed, 36x squared, negative 12x squared, negative 24x, plus 2x plus 4, and then some collecting of like terms. What's the biggest power out there? X cubes. So I see 24x cubes. Then we'll go after x squared, negative 6, and 36 minus 12 is 18x squareds. And x's I see 2. And 4 minus 24 minus 20x. And 4 minus 4 is 0. So let me check all those. 24x cubed, yeah, I like it. 30x squared, 18x squared, I like it. 2x minus 22 plus 2 is minus 20x. Yeah, I think it's pretty good. Anybody else feeling pretty good about that? Now I could go and factor it if I needed to. And in fact, it's got a great common factor of x, so I could go. So I'm not telling you in this homework that you have to factor yet. We'll get to that. But if it's adding between the brackets, you may as well start getting used to multiplying them out. because then we'll factor after that. If they're multiplied together, you're fine. Questions about that one? Is it good? Which part do you want to talk about? Okay, so I multiplied the 2 times everything there, and then I did the FOIL here. It's not called FOIL anymore because it's 3 terms by 2 terms, but I took this 9x squared and multiplied it by each, this -6 and multiplied it by each, and this 1 and multiplied it by each. Yeah, so it's like a triple FOIL. It needs a new name. Last one. I know there's another question there, but this is the last of these. Underline that first function and call it first or call it f. And then you're taking the derivative of that first function, of the f function, multiplying it by the second function. And again, this is another example of a question that probably could be done without the product rule. You could just multiply out the brackets. So there's derivative of the first times the second plus derivative of the second times the first. Let me check that. Oop, there's the first. So f prime g plus g prime f. Yes, very good. And I'll throw it out there again, trying to sideways move my way up to understanding why it is I have to multiply out these brackets. What is it about this situation that tells me that multiplying out the brackets is I'm probably stuck with it? Veronica? The addition between us tells us this isn't close to factored, so don't believe you're done. You're going to have to multiply out those sets of brackets. I don't think this one is nearly as bad an expansion as the last one. 8x squared plus 8x plus 16 plus 16x squared minus 32x plus 8x minus 16. Let's double check that step before I go any farther. 8x squared, 8x, 16, yes, 16x squared minus 32x plus 8x minus 16. Good. X squareds, I got 24x squareds. I got negative 16x. Do I? 24x squared, yeah. 16 negative, yeah. It all looks good. There'd be a nice common factor here. This would factor nicely if I had to go do it. We're not really on to factoring just yet, but it's coming. Or we'll factor these things at the end. What questions do you have? Question? This one? 8x plus 8x. Yeah, I put... Oh, no, because it's minus 32x. Jeez, I thought I double-checked that. Not that I can't make a mistake twice in a row. I've done it, but I didn't think I did. (16x squared) minus 32x plus. Is it good? Okay. That's going to be your problem. Like, what's funny in all this? The calculus today is shockingly easy. The only calculus I taught you all day is bring down the number out front and reduce it by 1. And then derivative the first times the second plus derivative the second times the first. That's the whole story. Go home. The rest of it is algebra. Right? Everything else that we've been doing today is algebra. And I got news for you. Calculus, for the most part, is not hard. It's the algebra that comes out of it that is really, really difficult. And that's where you need to pound through these questions. Practice wins here. You'll just get better and better as you practice them more, and those little mistakes will stop disappearing. You see, it's built into me. After all these years. How long ago since I sat in 30 years since I sat in the chairs where you are at a different school. But I do a line and then I check. I do a line and then I check. I don't cruise along. I hate that feeling. When I get 7 lines down, I'm like, oh, I forgot the 4 way up here. No, I automatically check every single line. More time here? Okay, before we lose perspective on what we were trying to accomplish with all this, let's go back to the type of question that this all started with. It says, find the equation of the line tangent to the function in example 1c at 1, -6. And let me just go get the derivative for a second from 1c. What did it come out to? 24x cubed. 24x cubed plus 18x squared minus 20x. And before we completely get so lost in the algebra, we lose perspective on what it is we're doing here, we now have a derivative function. And it says, find the equation of the line at 1, negative 6. So the x value here is 1. And I'm not even going to explain what I'm doing yet. I'm just going to take this 1 and plug it in. And we need to talk about what I have, because it's important to understand what we have here. F prime at 1, because that's the x value they gave me, is 24 plus 18 minus 20. I get 22. I got to check that because I don't want to get talking away and sped up in front of myself and make a mistake there. But if I put a 1 in there, I get 24. I get 42. I get 22. What does that mean? After all this, days of pounding our head on this stuff, what is the 22? Long, uncomfortable pause where your brain beats on it and go, yeah, what are we doing here? What was this all about? What is the 22? Maria? Yeah, it's this low. After all this work, therefore, m tangent equals 22. That's what we were doing the whole time. The derivative is a method to get the slope of the tangent. So after all that algebra, the slope of the tangent is 22. Now, don't lose sight of how beautiful that is, that this unbelievable function, which I'm not sure we could even graph, it's some kind of scary thing like this, we can jump right ahead and with not much. This isn't the worst algebra ever. We did ones not quite this bad in grade 9, distribution and collecting like terms. You know, like it's not the worst algebra ever. In a few short steps, bang, slope of the tangent, 22. Yeah? Pretty powerful stuff. So I'm not done. It said find the equation of the line tangent. So I got to do y equals mx plus b. Use my 22. Those of you who are using the new formula, the y equals mx minus p plus q, yeah, keep using it. Beautiful. I got no problem with it. I go back to this because some people didn't fall in love with that as much as they might have. Sub in 1, negative 6. So I get negative 6 equals 22 times 1 plus b. Negative 28 equals b. Therefore, y equals 22x minus 28 is the equation of the tangent. So in the middle of all this, we've been distracted by finding derivatives, and we will spend a lot of the chapter distracted by finding derivatives. But in the end, don't forget, we're just finding slope of the tangent. But now, of crazy, nutso, psycho functions, and we're handling them, well, let's call it reasonable. It's a reasonable process to finding them. Questions there? It just heats up from here, folks. Try to have a good night. Like, try to pound away on this stuff. Check those notes all the time. Like, go back to those notes and check them, like I suggested. I'm not trying to get out of you texting or emailing me. I'm just saying the notes sometimes have the exact answer to the question you're asking me, and so you got to get a little better at using those notes and the textbook. You know, they ask a weird question in the textbook, flip back and look through their examples and go, is there one sort of like this that can help me out? Okay.